In this lesson, we'll go over expressions. As I was looking for an icon for this unit, I typed in expressions, and of course emojis came up, so I thought it'd be fun to add that, even though math expressions are a little bit different. Specifically today, we'll understand mathematical expressions, we'll translate an expression into words, we'll translate words into an expression, we'll learn to evaluate and simplify expressions, and then we will apply expressions to word problems. So expressions look like what's on the screen here. N plus 4, negative 5x, 5 times x plus 1, 8x over 10y. And we want to think of expressions as just a bunch of math stuff. But expressions are helpful in translating a given scenario into math in order to help us problem solve. So that's why we deal with them and talk about them. So example number 1, translating expressions to words. And because my handwriting is already bad, the screen makes it worse, I've typed out what these expressions could be in words. So 7 plus n could be the sum of 7 and n, or just 7 plus n. N could also just mean a number, okay? 5s is 5 times s, or something like the product of 5 and s. 8x plus 3 is 8 times x plus 3, or the product of 8 and x plus another 3. X minus 11, pay careful attention to this one. This could mean 11 subtracted from a number, or rather 11 subtracted from x. If I say 11 subtracted from 100, you would write 100 minus 11, right? So a subtraction, or subtracted from, it's actually a little bit backwards. Or the difference of x and 11 would work. Going the other way around, translating words to expressions, use a number, so we'll use the variable x here. So if we're talking about the sum of 12 and a number, sum denotes addition. We're talking about 12 plus a number is denoted by x. 46 subtracted from a number, this is where it's backwards to be x minus 46. A number plus 3 and then comma times 2. So this could read a number plus 3 and then the whole thing being multiplied by 2. And the last one, 8 more than 7 times a number. So we have 8 more than is plus, 7 times a number is 7x. The equal sign. So we're going to talk about evaluating expressions, but before we do that, we have to talk about what an equal sign means. Whenever we have an equal sign, whatever's on the left has to be equal to the right, no matter what it is. So some examples are 60 seconds is equal to 1 minute. If I say I'm going to go somewhere in 1 minute, it's the same thing as saying I'm going to go somewhere in 60 seconds. Or when we talk about hockey in Las Vegas and talk about flour, we're talking about Marc-Andre Fleury. So when you have an equal sign, you can replace, like we replaced 1 minute with 60 seconds. It allows for a direct substitution or replacement. So when we talk about evaluating expressions, we substitute the given value, use the order of operations to simplify, and your answer should be another number. So evaluate the following expressions if a equals 3 and b equals negative 4. And all of the operations are preserved. So for instance, in example A, this is negative 5 times A times B. So when you substitute in the values for A and B, we're going to preserve that multiplication. So we have negative 5 times A times B. Okay, and so we just go straight across. This is negative 15 times negative 4, which gives us 60. So our answer is another number. For example B, we'll plug in 3 for A because A is 3, A equals 3. When you see A, you should think of 3 in this problem. 5 times A plus 7 times B. And then we use order of operations, so we'll do multiplication first. And 15 plus negative 28 is negative 13. For example C, this is negative 3 times b squared. So we plug in negative 4 for b. With order of operations, we're supposed to do exponents first. So we evaluate negative 4 squared first. Remember, this means negative 4 times negative 4. So this becomes 3 times 16, which is equal to negative 48. Sorry about that. When my dog likes to play, she just starts barking, so I had to stop her so I could continue this lesson. Okay, so these are examples of evaluating expressions. Next, simplifying expressions. So what we'll do is we'll get rid of parentheses, distribute, so we can see everything that we have. And then we'll combine like terms. So a refresher on like terms is, the way I like to think of like terms is I know that terms are alike if they can be added together and condensed into one. So for instance, $5 plus $12 would be $17. But if you were to add €5 plus €3, they're not alike. So you can't add them and combine them into one unless you do some conversions. Okay. So like terms are -8, 10, and 11. 2r and 3r. 8x, -10x, and x. So if you were to add or subtract those terms, you could reduce it or simplify it to one term. Some things that aren't like terms, 4x and 3x squared. The power of the variable is different there, so they're not like terms. 3q and -5p. The variable is different altogether, so they're not like terms. 8 and 3a, you can't add these together. One has an a and one doesn't. So again, there's a difference of variables. And when you simplify expressions, it should be another expression just a bit smaller. So starting off with example 1, we combine like terms. So the first step is to identify your like terms, and I typically mark them with some sort of symbol. So 3x and -5x are like terms, and 8, 9, and 8 are like terms. So in order to simplify this then, 3x plus -5x is -2x, and 9 plus 8 is 17. So this is one way you could write it. You could have also written the 17 first, okay? Or either one of these three is okay. If you do go to change the order, like I did in the last one, just make sure the signs are preserved. We determined that it should be positive 17. 17 should stay positive. It's a -2x, so 2x should stay negative, however you rewrite this. Example B includes an example of distributing. So minus, when you see minus there, you can imagine that there's a 1. And these parentheses denote multiplication. So before I can start combining like terms, I need to see what exactly I have. So this -1 distributes to the 2 and the x. So this becomes 7 minus 2, and then -1x. When we talk about like terms, 7 and 2 are alike. So this can be written as 5, and then -1x, or just 5 minus x. Okay, that x is still there. Even though it can't combine with anything, it needs to be part of your answer. This could also be written as x plus 5. So either of these are okay. Okay, so using expressions and applications. So use the given values, evaluate the formula, and make sure you use appropriate units. For example 1, P equals 2 times W plus 2 times L. If you remember, this is the perimeter formula for a rectangle. If L is 3 feet and W is 5 feet. So if L is 3 feet, we can plug 3 feet in for L. And if W is 5 feet, we can plug 5 feet in for W. So this becomes P equals 2 times 5 feet plus 2 times 3 feet. Okay, and then we simplify. 10 feet plus 6 feet gives us 16 feet total. For the second problem, A is 0.5 b times h, or 1/2 base times height, which is the area of a triangle. And again, we plug in the values given. So A is equal to 0.5, B is 1.7 inches, H is 3.2 inches. Okay. So when we multiply this out, you would be doing 0.5 times 1.7 times 3.2. Which is 2.72 for the numbers, but be careful, inches times inches is inches squared. Application number 2. So a movie theater sells a movie ticket for an adult for $12.75 and a movie ticket for a kid, 12 and under, for $9.75. Someone buys A adult tickets and K kid tickets. Okay, so we're going to talk about what all of these represent. I'm going to talk about them in a couple of different ways, because the most important thing is that you understand what the letters or the expressions are talking about. And I'll write some of these down for just certain ones. So what does K represent? So in this case, K is a quantity. and it represents the number of kid tickets. Okay. What does A plus K represent, part B? Well, A is the number of adult tickets and K is the number of kid tickets. So one way to think about this is the number of adult and kid tickets, or just the total number of tickets. Part C, what does 12.75A represent? Okay, so 12.75 corresponds to a cost. So when we take 12.75, our cost, and multiply it times a quantity, we're going to get a price or a cost for A adult tickets. So this is cost for A adult tickets. If you purchase one ticket, it would be 12.75 times 1. If you purchase 10 tickets, it would be 12.75 times 10. Okay. Similarly, part D, 12.75A plus 9.75K represent. Again, we're dealing with cost because the numbers, the coefficients of A and K, the numbers in front, are dealing with cost. This is a total cost. So this is A adult tickets, K kid tickets purchased. So this is total cost for A adult tickets and K kid tickets. The last one, what does the expression 100 minus the quantity 12.75A plus 9.75K represent? Well, in part D, we talked about this as a total cost. So we're taking 100 minus the total cost. The way that the homework is going to explain this is that it's money back. So let's say you go to the movie theater, you buy A adult tickets and K kid tickets, and you pay with $100. This whole expression represents what the money you'll get back. Okay, so we'll go to something different to help reinforce that. Let's say you go to the grocery store and your bill is $25, but you pay with $100. You're going to get back 100 minus 25, right? You'd get back $75. So the same thing is happening here. This is what you're paying with. This is the cost, so this would be money back. Thank you for watching. If you have any additional questions, please feel free to reach out to me.